Hello everyone, this is MrSovr, also known as Parker, and today we're going to go over the AGK 2.0 first tutorial, which is going to go over sprites. So AGK, also known as App Game Kit, is a wonderful software for developing your favorite games or utility softwares. It uses two-dimensional and three-dimensional graphics. It also uses a basic programming language that can be exported to any device that is iOS, BlackBerry, Android, Ouya, PC, Mac, and Linux. And it also holds a lot of complex API that is really simple and easy to use. Um, Also, to get App Game Kit, you have to go to thegamecreators.com. I've been using App Game Kit for like 4 to 5 years now. It is wonderful. Um, all I have to say is that's probably the best gaming software I've ever gotten in my life. So, moving on, a sprite is basically a two-dimensional image on the window that is the screen of the video game. You have to load in an image, which is a JPEG, a PNG, or whatever format that you have, and you convert it into a sprite. By doing that, you can actually have a two-dimensional object floating around in your video game. So, before we get too much into sprites and stuff, I'm going to go over the basic code of this project. Now, I'm assuming that people have actually understand some form of basic programming before this. You don't have to know a huge amount of basic programming, but I prefer you to probably read a good 2 to 3 chapters of a basic programming book just to understand the dynamics of the ifs, the loops, and all that. So we have our first line of code, which is SetWindowTitle. And right now I have it as Josh, but to basically show you what this function does, it basically just names your window. So I'm going to compile it and then run it just to show you an example. You can see it's Josh. So Josh right here and Josh right there. Now, of course, this is the sprite I'm going to be using, which is grass, very basic sprite. I'll get to that in a moment. So if I were to change Josh to my name, which is Parker, compile it, and then run it, it would change the window name. So instead of Josh, it's now Parker. So what exactly does the set window size do? Well, it kind of does what it says. You can set the actual size of the window in the video game. So let's just say we want to do 256 by 256. Of course, this right here is the width, and that is the height. Right here is whether if it is full screen or not full screen. So we compile it and run it. And as you can see, it's a really small image. Actually, the grass looks really nice in this size of the window. So that is how you actually do the size. Now I'm going to put it back to 786 and 1024. So the set virtual resolution is basically setting the window size but virtually. So the physical size will not change, but everything within the game will change. Now, for example, we do a poor quality of 256 by 256. You can see it's really fuzzy, right? That's the virtual resolution. Now let's say you want to equal it to the same size as the physical screen or window size. Now you can see that not only did the sprite shrink, but you have more room available on the actual window. And of course the sprite actually looks really nice. It's not as fuzzy. Of course it matters on the resolution of your sprite, whether if it's 256 by 256 or 1024 by 786, or even more or less. Okay, so now that we have the basics here, you can also know that the double slash is actually a comment. It doesn't affect the code. So you can put whatever you want. You can do slash slash, all that, compile it and run, doesn't do a thing. Still functions just fine. Okay, so when you are initializing variables, especially if you want to do a global variable or a a local variable. Yeah, I should probably add in a variable. Let's just say test var as integer. Okay, so a global variable means that anywhere in this code, just anywhere, it has access to that variable. Now, when it's a local variable like this, you only have it within this little function. If you go to an actual different function and you try to access the global variable without passing it as a parameter, it will not work. Of course, if you don't know what a function is, don't worry, I'll cover that later. But just think of it right now as the global variable could be accessed anywhere, and the local variable without the global command can only be accessed in its region. That's basically what scope is with programming. Again, I would prefer you to read a little bit about BASIC beforehand so you can kind of understand these concepts. I'm only touching on these concepts really lightly. Everything else, I'm kind of going full throttle and telling you how AGK works. So now that you have a basic understanding of the global and the local variable, of course you can do other things than just integer. You can do string. You can do float. Now, of course, I'm going to touch on this really quickly. The difference between an integer and a float, you can have decimals. Like you have a 0.3. Integer, you can only have 1, 2, 3, 4, 5, and so on. A string is basically a bunch of characters put together into a sentence. I'm not really for sure if you could do a char. Nope, you can't do a char. But you can do a string, you can do integer, you can do a float, all sorts of that stuff. So I'm going to put this back to an integer. And right here we have a load image. Now the thing is that's very vital, and I can't really show it on, I should have had it where I could show you on the video, but there is a folder. If you go to your project folder directory, there's a folder called media. That folder is where you put your media. You put, for example, this grass.jpg. You put that image right into the media folder. You type in this code, it'll automatically detect that there's an image in that directory. Now the load image simply just loads the image in the code and gives you an ID number. Now every image, first of all, every image, every sprite, every object, every text, every sound, every video. Wait a second, I think the video only has, you can only load one video at a time, but I could be wrong there. Again, that's a later video, but all those things require ID numbers. Now you can auto-gen an ID number, which I have right now. It's very easy. Well, it's really good if you're doing dynamic like stuff. If, for example, you're trying to make two-dimensional Minecraft, you need to generate technically an infinite amount of sprites. Of course, I'll probably crash the game if you don't have enough code to optimize it. But ultimately, you need to create all those things, and by doing it this way, you can easily do it dynamically. Now, another way you can do it is hard coding the number, which would be like this. Now, that is hard coding your ID number. Now, the thing is, though, since you don't have a variable, you have to remember this. So, if you want to create a second sprite, it would have to be 2 instead of the IMG. 2 is the identification number for this image. You can have multiple images that are the same source, like you have 2 grass.jpegs. Now I'm going to use the second second image, well, image and sprite, to do some demonstrations later on. But for now, we're just doing the basics of positioning a sprite, rotating a sprite, basic stuff like that. So we have the load image, we have the create sprite, we have the variables that are associated to the IDs of each of the sprites and the images. Now, of course, it's kind of self-explanatory. The create sprite converts the image into a sprite. An image can never be seen on the actual screen until you create it into a sprite. So now that you have a sprite, now you can just do this and not do anything with the sprite. have it like that. Technically, there's two sprites there, just overlapping each other. So again, before we move on to more sprite stuff, I'm going to tell you this little loop. This little loop is created by default. It's basically the main loop of the game. I'm not going to go over how the loop works. I assume that you already know how it works, but I guess I'll say a little bit. A do loop is basically an infinite loop until you break out of it. And I'll tell you how to break out of it soon. So let's say you have, how would I go over this? Okay, so here's a print command. A print command can display anything on the screen. So if I do print hello, you can sort of see. It's a little hard with the sprites. Here, let me do a quick command. So set sprite visible. Okay, another thing I want to point out is that the SPR_2 acts as a local variable. The local variable can go into a loop, but as soon as it's somewhere else outside the loop, or like in a function, it has no access to it. So I can compile this, run, and you can see the hello. This is how the print command works. Now, as you can notice, you can also see there's this huge number and it has a bunch of digits. This is your frames per second, screen FPS with 2 parentheses. Show you the actual frames per second of the video game. Now, why would you want this? You want it for debugging and also knowing for like optimization of your video game, which will go later on in benchmarking. So that's how the print command works. Now, there's also a different print command, which is kind of interesting. It's called print C. Now, I'll show you how that works. Well, before we do this, I'm going to add a second one. Which is print by. We can run this and you can see that there's a enter or return, so that instead of saying hello, then seeing by here and then the numbers, you see it as if you press the return key every time. Print automatically does this. Now let's just say you have a print and then you want to put another print right beside it. Let's just say you wanted to convert the by to frames per second. And instead of having it up here, or I'm sorry, this number down here, you want, whoops, that's going off the screen. Sorry about that. Instead of having the numbers right here, you want the numbers to be over there. So, exit out of that. And instead of having just print, you do a thing called print C. And as you can see, there's no return. So you have two prints. You have a normal print and then you have a print C. A print C does not return, so this print is right next to the other print. So that's how that works. I'm going to delete that. I'm also going to delete this because it's kind of been in the way. Now the last thing is the sync. The sync is basically updating everything. The screen, the video game, the physics, everything. You do need the sync in the loop or else nothing will work. So now that we have that going, I guess I'll explain this. It's very simple. Set sprite visible basically sets the sprite visible or not. Of course, setting it to 0 means it's invisible, setting it to 1 is visible. And of course, you use the ID number of the sprite, which is SPR and SPR_2. So since we do want these visible, I'm going to set the first one visible. And let's just say we do set sprite position. SPR. Let's do 100, 100. So this was sent through X position 100 and Y position 100. And of course, this is based on pixels, or the actual measurement that the window uses. So you can see that the sprite is slightly moved from the last time we saw it. And of course it's by this corner right here is at 100 by 100. Now, since you've read your book, hopefully, for basic, we're going to add in a variable. Now, the most interesting thing is that you can just do a equals 0. It would automatically know it's an integer. Now, to actually know if it's not an integer, if you want a string, you have to put a $sign next to it. But these are only for local variables. If, for example, you set this to string up here, you don't have to put the $sign on there because the compiler already knows that, oh wait, that's a string, not an integer. But if you're doing local variables, you need it to have an actual $sign. Well, wait, I'm sorry. That's not totally correct. Dang. I'm sorry about that. Technically, the global just means that it's accessed anywhere. Assigning it to integer or string means you don't have to put the actual $sign. I do apologize for that. It's been a while since I've been doing videos, so just bear with me. So let's get rid of that. So back to the sprites. I'm going to, well actually wait a second, I kind of needed that there. I'm basically going to make the sprite move. By doing this, I'm going to be adding 1 to a variable by itself, so it's going to increment to 1, 2, 3, 4, all the way to infinity. I'm going to do it based on the x position. So I'm going to add a to 100, which would be the x position. And I guess I might as well print the x while I'm at it. Or the a, I meant. I'm sorry, not the x. Oops. So you can see the a is right there, and the sprite is moving. Because that is the x-axis, and we're adding 1 to the position every time it goes through the sync. Now let's just say that was going too fast, but at the same time you want it to still be a equals a plus 1. And let's just say overall you want the program to run slower. Let's just say you wanted that. Now you can put a delay, which would be sleep. Now we can do 500, which I believe 1,000 is 1 second, so it'll be half a second delay. As you can see, the increment is a lot slower because it goes for a delay. It's almost like the game is lagging. Just wanted to put that in there. Okay, so now we actually know how to do the position. Now let's just say instead of knowing what A is, we want to know what the actual sprite position was. So we can do get sprite x. Then of course we have to put the sprite ID number. Compile it and run. As you can see, it's actually a float. So you can see the progress of the movement of the sprite as it moves off the screen. And that's how you can actually get the x position of the sprite. And you can also move the sprite. Now we can also add a to the y, which would allow us to move in a diagonal direction. Of course, we want to do the print get sprite y SBR. Now when we run it, it goes in a diagonal, and we have the x and the y. Okay, so that's really cool. So how about I give you some information about some core features, like this thing called getPointerX. Now getPointerX is basically telling you where my cursor is on the screen as the x coordinate. And for y it's the same thing. So how about if I controlled the mouse with my sprite? That's quite simple. We do set sprite position, set the ID number for the sprite, then we would do get pointer x, then get pointer y. Now, wherever my mouse is, it's following, or the sprite is following my mouse, which is really, really cool. So we're going to do that for the first one. We're going to reactivate the second sprite, which would be that. And this time we're actually going to make the size of the sprites smaller, the second one. 256 by 256. This is the width and this is the height. As you can see, the second sprite is a lot smaller because we adjusted the size. Okay, so this is all cool and all. So another thing I need to add in to the tutorial is set sprite rotation. Whoops, did I spell it right? Oh no, it's set sprite angle. Okay. So we'll do this for the sprite, and we'll do or the first sprite, and we could do 10 degrees. As you can see, now it's rotated, which I think is really cool. So, how about if when we actually click down and move down, the image would rotate, but if I unclick, it would just move like this. Okay, so close that. We can set the angle like that. So I'm going to introduce the, I'm going to introduce the if statements. I'm going to do if, and you do not need parentheses around the if statements, just to let you know. And you don't need a then at the end unless you're going to actually have the code go on one line. But if get pointer state, which the get pointer state means that if it's equal to 1, that means I'm clicking down. If it's equal to 0, I'm not clicking it. Or the mouse, that is. So if it is equal to 1, I'm going to use the y-axis for the rotation. So I'm going to set sprite angle, SPR, get pointer y. So I'm going to get rid of this code right here because it would interfere with it. And then I'll do an end if. So let's see what happens. Oops. Oh, don't put two equal signs. I'm sorry. That I'm thinking it's C++ or something now. Okay. So when I click down and I move my arrow based on the y-axis, it can rotate. And it stays that way, which I think is really cool. And you can still move your mouse around, it'll still follow you. Now one last thing I'm going to show before the end of the tutorial is collision of two sprites. Now that we know clicking a mouse and actually getting the coordinates of a mouse to rotate a sprite angle with the sprite ID, of course. So now we're going to do another if statement, if get sprite collision, which we do the first sprite ID number and then the second sprite ID number equals to 1. We'll do a thing called a message. Oh wait, no, that might actually be a little hard to do. So I'm not going to do a message just yet, but I'm going to do a print. Actually, before that, I'm going to do set print color. Now, setting the print color changes the text color, basically, of the print. So there's red, green, and blue. So I'm going to do red. And then I'm going to do print the two sprites collided. And that ends my statement. So, when I run this, as you can see, when the two sprites touch, the text appears. Of course, I can still do all this. And it's even cool because even though I'm spinning, it detects it even with like the slight little corner hitting it. What's really cool is too, you can like flip it around and stuff like that. You can move it and turn it at the same time, whether if I'm clicking it or not, or if I'm clicking it or not, based on the rotation. I'm sorry, let me say it one more time. When I click down, I can rotate, but I can still move it around. So when I do both, I can still move around while rotating it. So that concludes this tutorial. I hope it was really good. It's my first video in a long time, probably over a year, that I've actually done a tutorial on something. And I hope you enjoy it. I'm going to work hard on the next several videos I'm going to be putting out there. I'm going to do more sprite commands, 3D commands, camera commands, all sorts of fun stuff. So this is MrSovr, also known as Parker. Please subscribe, like the video, comment, and share with your friends. I am sure to see you later.